Today we're going to use our existing algebra skills for solving equations and extend them to rearrange a formula and change its subject. So I'm going to do this with a series of parallel examples. We'll look at some equations that you should already be able to solve, and then we'll look at how those skills solving that particular equation can be used to rearrange a particular formula which is very mathematically similar. Here we go. So first example, let's start with a simple two-step algebra equation. 3x minus 8 equals 13. So I'm going to solve this by first of all getting the 3x term on its own, and I do that by adding 8 to both sides. 3x equals 21. And then I can get x on its own by dividing both sides by 3. So 21 divided by 3, and that will come out as 7. Underline my answer. So the steps we've used to solve this particular equation, I'm going to use those same kind of steps with this formula. So I have ax minus m equals k. And usually on these kind of questions, you'll be told which variable you're looking to make the subject. I'm going to be making x the subject. The question will typically put the letter it wants as a subject to one side in a little set of square brackets like that perhaps, or it will tell you in the text. So parallel move here. The first thing I did with the equation was add 8 to both sides, and in mimicking that step I'm going to get rid of the minus m by adding it to both sides. So I'm adding m to both sides. That means my next line is now going to read ax equals, I've got rid of minus m by adding it, but on the right hand side I'm going to have to add m so that the equation maintains balance. Finally, I want x on its own, and x is currently being multiplied by a. When a letter is written adjacent to another letter like that with nothing between them, it means they're multiplying. So I will divide both sides of my equation by a. X equals k plus m all over a. And I've now changed the subject of this formula. Initially the subject of this formula was k, because k was being explicitly defined as a process of the other variables. I've reworked that so that x is now explicitly defined as a process of k, m and a. So that's the first one. Okay, second example, EG2. Let's make it a little bit more complicated here. Let's have 27 subtract x divided by 4 equals 22. Now there are a number of things with this equation that are initially bothering me. One of them is the fact that x is being divided by 4. The second one is that the x term is negative. And remember, we talk about terms owning the sign in front of them. So this x over 4 term owns that minus sign. It's a negative term. So the first step I might choose to do here is to add this term to both sides. And the effect of doing that, if I add x over 4 to both sides, it fills in the term there, and I'll have to put it on the right hand side. So I get 27 equals 22 plus x over 4. This is now a positive x term, which is preferential for working. Now I'm going to try and get this positive x over 4 term on its own, and that means I need to get rid of this 22. And again, in maintaining the balance of an equation, I'm going to have to take 22 from both sides. So I will have 5 on the left hand side, and I'll just have x over 4 on the right hand side. So 22's gone here. This has gone down by 22 to 5. Finally, x is divided by 4 to give 5. So if I want to get x back to its whole value again, I'm going to have to multiply it by 4 to overcome the fact that it's being divided by 4. And I've got to do that to both sides to maintain the balance of the equation. So x over 4 times by 4 will just be 1 whole x, and 5 times by 4 will be 20. A good thing to do at this stage is maybe do a quick substitution back into the equation with my answer and check it works. 20 divided by 4 would be 5, 27 take 5 would be 22, so I'm confident that that's the right answer. So let's have a parallel formula that we're rearranging then. So let's have t minus x over v equals b. And so, mimicking the steps, I want to overcome the value, the term with x in it being negative. I want it to be positive to start with. I just find that easy to work with. So I'm going to add x over v to both sides. T equals b plus x over v. Filled it in here. It's appeared on the right side as positive. Mimics what went on over here. Next, I'm going to get the x over v term on its own by taking b from both sides, minus b. So t minus b equals x over v. Sometimes in some textbooks and in some videos, and indeed some teachers might describe this process as a term kind of crossing the equal sign, like it's some kind of bridge and magically changing sides as it does so. That might be an observable feature of what's happening with the algebra, but you should really consider what's happening in terms of how you are manipulating both sides of the equation and how you're maintaining the balance. So finally, last step then, to get x on its own, I'm going to multiply both sides by v. So multiply by v. I'm going to need a bracket for that. So v times by t minus b equals x. It doesn't matter that x has appeared on the right hand side. Some people get very pedantic about it having to be x equals and then the answer. And it doesn't matter if it says v brackets t minus b equals x. I've still explicitly defined x in terms of the other variables, so x is still the subject. Now, I'm going to call this example here 2a because I want to look at another way I could have done this. Whether you choose to, once I've made the x term positive, whether you choose to take 22 from both sides and then multiply by 4, it is possible to do these operations the other way around, but you've got to be careful. So let's call this next one example 2b. It's going to be the same question, but we're just going to think a little bit differently. That first step, I'm not a fan of processing a negative term. It's to do with the fact that when you work within inequalities, and if you're not careful with negative x terms, you can run into problems. If you're automatically training yourself to make your x term positive, then things will be simpler when you get to that work. 27 equals 22 plus x over 4. Now at this stage you might decide, I don't like that fraction. I don't like there being fractions in my working here. I'm going to clear fractions. And the way I'm going to do that is I'm going to make every separated term within my equation 4 times bigger. So terms are separated by addition and subtraction signs. So that's a separate term, that's a separate term, x over 4 is a separate term. So we'll multiply the whole equation by 4. So 27 times by 4 is 108, if my maths is right. And 22 times by 4 is 88. And then x over 4 times by 4, well, the whole point of multiplying by 4 is to make this term a whole value of x. And then this is now quite simple to finish off. I can take away 88 from both sides. And x is 20. No surprises there. I'd have been a bit worried if I got a different answer. And let's just look at how that slight change of approach would be reflected in solving the formula rearranging bit. Same equation. Same first move. So t equals b plus x over v. And at this stage I might decide that the v... Come on, Mr. William, tidy that up. Right, I might decide that the v dividing that x term is annoying me and I want to get rid of it. I want to clear the fractions, so I'm going to, in a parallel move, I'm going to multiply through by v. So each term is going to be v times bigger. So I've got t times v. Could have written v times t, but I'm going to write tv because it's alphabetical. bv plus x. And then finally, to get x on its own, again, parallel move, subtract the bv term from both sides. So tv minus bv equals x. Now, this formula might look like it's different to this formula here. And maybe if one of these formulas was what was written in the back of the answers for your textbook and you're trying to look up, have you done the question right, you might be a bit concerned that you don't appear to have exactly what's written in the book. But this is a quick lesson in being aware of equivalent formulas. If I expand this, if I multiply this bracket out, you should see that I would just get this variation of the way the formula is written. So these two formulas, these two ways of writing x as a subject are equivalent. Right, let's do another example. So let's look at an equation where we have x as a denominator in a question. So let's have 15 divided by x plus 7 equals 12. So a couple of ways I could go about this one. I'm going to first of all get rid of the fact that x is a denominator. So if I'm going to get rid of x being a denominator, it means I need to multiply every term by x. 15 divided by x times by x is just 15. 7 times x is 7x. 12 times x is 12x. Now I have x's on both sides of the equation here, and I've got to be a bit careful when this happens. If I'm not careful in how I choose to process the x's, I can end up having to repeat a step. So the simple rule here is you process the colder x term. 7 is colder than 12. 7 degrees will be colder than 12. I'm going to get rid of the 7. The 7x rather. So let's take 7x from both sides. 15. 7x is gone. Take it from here. 5x. And then finally, to get x on its own, divide both sides by 5. That's a division sign. 15 divided by 5 equals x. And x equals 3. Underline your answer. And so, mimicking a formula where that happens, let's have p over x plus q equals, let's have a t. So I'm clearing my fractions. I'm going to multiply every term by x. P divided by x times by x is just p. The other terms, don't forget, they both get multiplied by x. Now this is slightly awkward here because again I've got x terms on both sides, and what I need to do is put my x terms on one side and my non-x terms on the other. So I'm going to subtract qx from both sides. P equals tx minus qx. And I can tidy things up here by factorising the x out of these two terms. So P equals x brackets t minus q. Final step to get x on its own is to divide by the coefficient of x, the thing that is multiplying x. And in this case, what's multiplying x is the whole bracket there. So I'm going to divide by the bracket t minus q. Still on screen, yep. So P divided by t minus q, put it in a bracket if you want, or just make sure that the division bar goes all the way over t minus q, equals x, and underline my answer. So hopefully these examples should give you a little bit of guidance as to how you should proceed with questions on this topic. A few other points that I feel it's important to point out here. Your layout is important. Space your work out. Leave a line between your steps. It gives your eye a bit more room to look at what's going on and not be confused by too many algebraic terms being squished up together. Secondly, try and keep terms lined up as much as is reasonable. If your equal signs are stacked up through the question, then it allows you to see how things are moving within the equation, what the movement is. And I feel it's also important to put down the operations in the margin, because this indicates an understanding of what it is you're attempting to do at any given stage. If you can't categorically say what the step was that you were trying to do in rearranging your subject, then it's likely you don't really understand what you're doing, and you need to go back to more basic questions and do those questions to the point that you can definitely put down your operations, and then it's much clearer that you understand what's going on and your work is rigorous. Okay, thanks very much.